Hello my dear students, welcome back to my channel, that is Maths by JJ ma'am. So now I am going to discuss about the determinant synopsis. What are the important formulas which are uh, very helpful for your upcoming KCT 2026. So now I will be giving you some of the very important synopsis here. Okay, so basically determinants, you know how to calculate the determinants. For example, I am just giving you a very simple example, that is order to determinant. For example, it is 1 2 3 4. This is very basic, huh? So 1 4 minus 6, which is nothing but minus 2. Then similarly, you know how to calculate the order 3 determinant. So now the main part, the additionally what we are going to learn. So this is already I have done a singular matrix. Okay, in your NCRT. What do you mean by singular matrix? A square matrix is said to be singular matrix if its determinant is equals to 0. Then comes a non-singular matrix. So what is the definition of a non-singular matrix? So determinant of A is not equal to 0. See, there are two types of matrices here basically, which we are going to use it in determinant chapter. Singular matrix, which is a square matrix, is said to be singular matrix if its determinant is equal to 0. Non-singular means if its determinant is not equal to 0. Okay, this is what you have learned at the beginning. Now, the next very important point here is, if A and B are two matrices of the same order, then the next synopsis formula, determinant of AB is equal to determinant of A into determinant of B. Next, the same way if I ask A into A dash, which is nothing but determinant of A into determinant of A dash. A dash is nothing but the transpose of this matrix A. So now, so basically determinant of A and determinant of A dash both will be the same. So you can write this as a determinant of A the whole square. Okay, this is about related to determinant. Next, a few more after this. In NCRT, what you have learned here is area of a triangle, student. So the basic formula here is to calculate area of a triangle using determinant is 1 by 2 x1, x2, x3, y1, y2, y3, 1, 1, 1. So this is the formula to calculate area of a triangle using determinant. So 1 by 2, first column x1, x2, x3, second column y1, y2, y3, 1, 1, 1. Now here there are certain conditions we have. So if suppose the area of a triangle is equals to 0, then the points are called as collinear. Okay. ಈಗ ಏರಿಯಾ 0 ಇತ್ತು ಅಂತಂದ್ರೆ ಪಾಯಿಂಟ್ಸ್ ಏನಾಗ್ತವ, ದೇ ವಿಲ್ ಬಿ ಲೈಯಿಂಗ್ ಆನ್ ದ ಸೇಮ್ ಲೈನ್. ಸೊ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ದ ಪಾಯಿಂಟ್ಸ್ ಆರ್ ಕೋಲಿನಿಯರ್. The condition for collinearity is the area of the triangle must be equal to 0. So this is the next part. After the okay student, now once we have learned this one, then later on what there are certain things that we have learned here is minor of an element. Okay, minor of an element, which is denoted by mij. Okay, by deleting its corresponding row and column, you will be getting minor. Then comes here cofactor of an element. Cofactor of an element is denoted by aij, whose formula is minus 1 raised to I plus j into mij, where mij is the minor of an element. So once if you have got minor, then the next step is finding out what cofactor of an element. So once we got all the cofactors, we have to write cofactor matrix. So once it is done with the cofactor matrix, the next step what you are going to learn here is adjoint of a matrix. Okay, student. So once we got the cofactor matrix, then we need to calculate adjoint. So adjoint of A is denoted by ADJ of A, which is nothing but the ಟ್ರಾನ್ಸ್ಪೋಸ್ ಆಫ್ ಕೋಫ್ಯಾಕ್ಟರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್. ಓಕೆ, ನೀವು ಕೋಫ್ಯಾಕ್ಟರ್ಸನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ ತಕ್ಷಣ ಕೋಫ್ಯಾಕ್ಟರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಬರೀತೀರಿ, ಅದರದ್ದು ನೀವು ಟ್ರಾನ್ಸ್ಪೋಸ್ ತೊಗೊಂಡ್ರೆ ನಿಮಗೆ ಅಡ್ಜಾಯಿಂಟ್ ಆಫ್ ಎ ಅಂತ ಸಿಗುತ್ತೆ. ನಾ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಈಗ ನಾ ಸಪೋಸು ಆರ್ಡರ್ ಟು ಎ ಈಸ್ ಈಕ್ವಲ್ ಟು ಸಮಥಿಂಗ್ ಲೈಕ್ 1 2 4 -2 ಇದೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ, ಆ್ಯಂಡ್ ದಿಸ್ ಇಸ್ -3 ಸಮಥಿಂಗ್ ಐ ಟೇಕ್. ಓಕೆ, ದಿಸ್ ಇಸ್ -3. ಸೊ ದಿಸ್ ಈಸ್ ಆ್ಯನ್ ಆರ್ಡರ್ ಟು ಸ್ಕ್ವೇರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್. ಈಗ ನನಗೆ ಇದರದ್ದು ಅಡ್ಜಾಯಿಂಟ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದಿದೆ. ಸೊ ಐ ನೀಡ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ದ ಅಡ್ಜಾಯಿಂಟ್ ಆಫ್ ಎ. ಇದಕ್ಕೆ ಶಾರ್ಟ್ಕಟ್ ಮೆಥಡ್ ಇದೆ. ಓನ್ಲಿ ಫಾರ್ ಆರ್ಡರ್ ಟು ವಿ ಹ್ಯಾವ್ ಶಾರ್ಟ್ಕಟ್. ಸೊ ವಾಟ್ ವಿ ನೀಡ್ ಟು ಡೂ ಹಿಯರ್ ಇಸ್ the diagonal elements has to be interchanged. Okay, the diagonal elements should be interchanged, but non-diagonal elements we have to change the sign. That is -4 and this becomes +4. So this is the shortcut method to calculate adjoint of A in case of what? Order 2. Now there are certain points are there, formula directly which will help you to calculate for CET 1. So there are certain formulas we have. A into adjoint of A into A, which is always equal to determinant of A into I. ಕೆಲವೊಂದ್ಸರಿ ಈ ಥರ ಡೈರೆಕ್ಟ್ ಕೇಳ್ತಾರೆ, ಅಲ್ಲಿ ನಿಮಗೆ ವಾಟ್ ಇಸ್ ದ ಡಿಟರ್ಮಿನೆಂಟ್ ಆಫ್ ಎ ಅಂತ ಕೇಳ್ತಾರೆ. ಸೊ ಪ್ರೀವಿಯಸ್ ಇಯರ್ಸ್ ಕ್ವಶನ್ ಪೇಪರ್ ನೋಡಿದ್ರೆ ನಿಮ್ಗೆ ಗೊತ್ತಾಗುತ್ತೆ. ಸೊ ನಾವು ನೆಕ್ಸ್ಟ್ ಎ ಇಂಟು adjoint of A into A is equals to determinant of A into I. Next, this is very important. Adjoint of A, determinant of adjoint of A is always equal to determinant of A to the power n minus 1, where n represents the order of the matrix. So ಇದು ಬಹಳ ಇಂಪಾರ್ಟೆಂಟ್ ಅದ. ನೀವು ಮತ್ತೆ if you see the PYQs, you can make out that so many questions have been asked on this particular formula. Next, there is one more, adjoint of AB. So finding the adjoint of AB, which is nothing but adjoint of B into adjoint of A. This is reverse law ಅಂತ ಕರೀತೀವಿ ನಾವು. So adjoint of AB is equals to adjoint of B into adjoint of A. That is the next formula. Then after this, related to what? Inverse. AB inverse is equal to B inverse A inverse. Then one more, A inverse the whole inverse is equal to A itself. Okay, that is related to inverse. Then again one more important, just in the previous video I have solved example based on this. The determinant of A inverse is always equal to 1 upon determinant of A. Determinant of A inverse is equal to 1 upon determinant of A. Then next is adjoint of KA is equal to, which is adjoint of KA is equals to K to the power n minus 1 into adjoint of A. A very important formula. If any question is based on KA, K ಅಂದರೆ ಸ್ಕೇಲಾರ್ ಆಯಿತು, A is a matrix. So adjoint of KA ಬೇಕು ಅಂತಂದರೆ K to the power n represents the order of a matrix. Then n minus 1 into you have to do adjoint of A. This is very very important. Next ಬರುತ್ತೆ adjoint of A, determinant. Okay, very important. Adjoint of A, which is nothing but determinant of A to the power n minus 1 the whole square. ಇದು ಕೂಡ ತುಂಬ ಇಂಪಾರ್ಟೆಂಟ್ ಒಂದು ಸಿನಾಪ್ಸಿಸ್ ಅಥವಾ ಫಾರ್ಮುಲಾ ಅಂತ ಅನ್ಬೋದು. Determinant of adjoint of A is equal to determinant of A to the power n minus 1 the whole square. So these are some of the important formulas which are related to the chapter determinants, which will help you to solve some direct questions, students. Please make a note of it. Now, few more points regarding the determinants I am going to discuss here, student. So this is nothing but one important point is a square matrix A. A square matrix A inverse has no inverse. ಇದು ಕಂಡೀಷನ್ ಏನಿರುತ್ತೆ ಅಂತಂದರೆ ಡಿಟರ್ಮಿನೆಂಟ್ ಆಫ್ A is equals to 0. ಅಂದರೆ ಇಟ್ ಈಸ್ ವೆರಿ ಕ್ಲಿಯರ್ that if the matrix is singular, then a matrix doesn't have its inverse. So to have an inverse for a square matrix, what must be the condition, student? Okay, has inverse antantandre, has inverse means the matrix should be not equal to 0. That means it should be a non-singular matrix. Okay, these are the two conditions. Next, suppose student there is a determinant, I'll say, that is nothing but a of x, b of x, c of x, then p of x, q of x, r of x, then next one is m of x, n of x, and then say something s of ex I will take. If this is the thing, then if I want to calculate a limit as x tends to 0, then delta of x will be. So you have to calculate individual limits. Okay. So you have to calculate what? Individual limits of all these functions. ಸೊ ಬೇಸಿಕಲಿ ಇಲ್ಲಿ ಏನಿರುತ್ತೆ ನಿಮ್ಗೆ ಗುರುತದ ಎಲ್ಲರಿಗೂ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಥವಾ ನಾವು ಡಿಟರ್ಮಿನೆಂಟ್ ತೊಗೊಂಡ್ವಿ ಅಂತಂದ್ರೆ ಆ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಮತ್ತು ಡಿಟರ್ಮಿನೆಂಟ್ದಲ್ಲಿ ಯು ಕ್ಯಾನ್ ಹ್ಯಾವ್ ಎನಿ ರಿಯಲ್ ನಂಬರ್, ಎನಿ ಕಾಂಪ್ಲೆಕ್ಸ್ ನಂಬರ್ ಆರ್ ಎನಿ ಟೈಪ್ ಆಫ್ ಫಂಕ್ಷನ್ಸ್. ಸೊ ಅಲ್ಲೇನೂ ರಿಸ್ಟ್ರಿಕ್ಷನ್ಸ್ ಬರೋದಿಲ್ಲ. ಸೊ ಈ ಥರ ಒಂದು ನಿಮಗೆ ಡಿಟರ್ಮಿನೆಂಟ್ ಕೊಟ್ಟಾಗ ಈ ಕಂಪ್ಲೀಟ್ ಡಿಟರ್ಮಿನೆಂಟ್ದು ಲಿಮಿಟ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು ಅಂತಂದರೆ ದ ಇಂಡಿವಿಜುವಲಿ ಯು ನೀಡ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ದ ಲಿಮಿಟ್ಸ್, ಸ್ಟೂಡೆಂಟ್. So limit as x tends to p of x, limit as x tends to 0 q of x, limit as x tends to 0 r of x. Then here also limit as x tends to 0 m of x, limit as x tends to 0 n of x, and limit as x tends to 0 s of x. This is how we calculate limit of an entire determinant. Okay, please note down this particular formula. Okay, now let us go with the one more formula related to determinant. So delta x is given as where the first row is having all the functions, but whereas in case of second row and third row we have constants. So in that case, if I want to calculate the derivative of this particular delta x, it's very simple, student. So see, d by dx of delta x means I need to take the individual differentiation. That's it. Okay. So f of x derivative is f dash of x. G of x is g dash of x. H dash of x. Keeping the remaining two rows elements as usual, which are nothing but common. They are constants. So this is how we do the calculation of derivative of a determinant. So for the more videos, for the more content, student, we have hardly very less time for the upcoming KCT. So possibly ಎಷ್ಟು ನನಗೆ ಸಾಧ್ಯ ಆಗ್ತದೆ ನಾನು ಅಪ್ಲೋಡ್ ಮಾಡಲಿಕ್ಕೆ ಟ್ರೈ ಮಾಡ್ತೇನೆ ವೀಡಿಯೋಸನ್ನು. ಸೊ ಐ ಹೋಪ್ ದಿಸ್ ವಿಲ್ ಹೆಲ್ಪ್ ಯು ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ವೆರಿ ಆಲ್ ದ ಕ್ವೆಶನ್ಸ್ ಆನ್ ಡಿಟರ್ಮಿನೆಂಟ್ಸ್. ಸೊ ಪ್ಲೀಸ್ ಲೈಕ್, ಶೇರ್ ಆ್ಯಂಡ್ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮೈ ಚಾನಲ್. ಆ್ಯಂಡ್ ನೆಕ್ಸ್ಟ್ please wait for my next videos. Please subscribe my channel. Okay, thank you.